Hello, my name is Emily, and I'm going to guide you through this presentation of ExhaustiF SWIFI, a tool that will help you find faults in your software to improve its reliability. In a critical software system, it is highly important to test for errors in order to reveal the presence of bugs, but this can be more complicated than it first appears. Fortunately, ExhaustiF SWIFI can be used to find these errors by injecting hardware faults and software errors in your systems under test. Detection of these weaknesses allows ExhaustiF SWIFI to give feedback to the developers, who can then improve the reliability of the software and correct any faults found. Let's take a look at the architecture of ExhaustiF SWIFI. This tool is made up of two software components, which run in separate machines. The EEM, which stands for the ExhaustiF SWIFI Experiment Manager, and the FIK, the Fault Injection Kernel. The EEM is the core component of ExhaustiF SWIFI, and here is where the experiments are configured and managed. The EEM also sends commands to the FIK regarding which faults need to be injected. The FIK is a small but vital component in ExhaustiF SWIFI. This component is very light and takes up less than 120 kilobytes. The FIK is loaded into the system under test and in charge of injecting the faults. ExhaustiF SWIFI is capable of injecting a variety of faults and errors needed to shield your software from attacks. This tool is able to inject software errors, processing errors, network system errors, file system errors, and hardware faults. In addition to being able to inject these errors and faults individually, ExhaustiF SWIFI is able to create experiments combining different errors. Another important feature is that this tool is able to specify the exact instant when these faults will be injected, as well as their duration. ExhaustiF SWIFI has a user-friendly graphical interface and makes use of the latest Eclipse 3 technology. The tool is Java-based and therefore runs in both Microsoft Windows and Linux. All ExhaustiF SWIFI data is stored in a MySQL database, which makes this information very easy to access using other external programs. As you can see, ExhaustiF SWIFI has versions for MS Windows and Linux platforms. ExhaustiF SWIFI can be introduced at any point in your software development life cycle, during any of the development, integration, or testing phases. We are now going to show you how your company can make use of ExhaustiF SWIFI. And to do this, we will take a look at examples in the following sectors: transportation, aerospace, defense, energy, and biomedical. Let's take a look at an application used in the transportation sector. For example, software which controls the braking system of a high-speed train. Imagine that the memory space in the system where the speed information is stored is damaged. How will the software behave? Will the software be able to sense that there is an error in the memory space? Will the train stop safely? In a critical software system environment, it is important to catch these errors before they occur. ExhaustiF SWIFI is able to inject errors in certain parts of the RAM memory, therefore allowing the developers to see exactly how the system will react. Let's now take a look at the aerospace sector. The application we have chosen is a software system that controls the vacuum pressure of an aircraft. Imagine that the pressure value data received has been damaged because the place where this information is stored has been corrupted. Will the software be able to stabilize the pressure in the cabin? In the real world, this error could have serious consequences. The application would need to have error recovery routines to use in such circumstances. ExhaustiF SWIFI is able to manipulate and corrupt any data which will be accessed and used by the programs under test. Now let's move on to an example in the defense sector. We have chosen to look at a software system that guides missiles. Imagine that a communication error occurs in the system which damages the positional information. Will the system crash or be able to recover from this situation? In today's world, software embedded in systems used in the defense sector needs to be dependable and reliable. ExhaustiF SWIFI is able to generate unexpected data values to help developers find software faults. We have divided the energy section into two categories. First, let's take a look at the energy sector regarding nuclear power. We have selected an application that receives information of radiation levels in real time from electronic meters. Imagine that for some reason the data received does not correspond with the actual information. This makes the application believe that there is an increase in radiation levels. Will the system understand that this data is incorrect? Failure in a nuclear plant can have catastrophic consequences. Therefore, it is highly important to assure the reliability of the software being used. With ExhaustiF SWIFI, it is possible to specify the exact instant when the fault will be injected, as well as the duration. The second category of the energy sector that we are going to take a look at deals with oil and electricity. In this case, we are going to consider a software that remotely controls an automatic shutdown process at an energy station. Let's imagine that the system where this software is running is overloaded, making very little memory resources available for this application. Will the application crash? Does the application have error recovery routines? ExhaustiF SWIFI is able to expose faults deeper in the systems by leaving the applications with low memory resources, allowing the developers to find execution paths which may contain errors. The final sector we are going to take a look at is the biomedical sector. We have selected an application that controls and regulates medical diagnostic appliances. Imagine that the diagnostic appliance becomes unavailable. When human lives are at stake, the reliability of diagnostic equipment is fundamental. If the software is not able to access sensitive data, such as password and identification information, the system cannot start up. In this case, how will the system recover? ExhaustiF SWIFI is able to simulate a software crash by limiting access to data files. This provides valuable information for the software developers. We are now going to take you on a tour of the main screens you will see in ExhaustiF SWIFI. ExhaustiF SWIFI provides an easy-to-use interface, enabling the users to easily navigate through the program. Here you are able to see the project navigation screen. The developers can document all project-related data and view the structure of ExhaustiF SWIFI. Each of them can be accessed through a tree navigation screen. A new project contains experiments, injections, and faults. In this example, we can see two different projects. ExhaustiF SWIFI is able to contain an unlimited number of projects to speed up the testing process. In this first project example, we can see a testing scenario for a Linux system which contains one experiment. This experiment reproduces one injection failure scenario, which contains two different types of faults. Once the developers have entered all of the experiment parameters, they can move on to the experiment screen. The set of test experiments can be created with specific information regarding each experiment. For example, the maximum execution time for each experiment, measured in milliseconds, can be entered. After introducing the experiment specifications, ExhaustiF SWIFI is able to check and review all information entered for validation. After entering the experiment information, the developers move on to the injection screen. Here, the duration and outcome reading of each injection is configured. The configuration time details will be the same for every fault injection in this experiment, making ExhaustiF SWIFI a very flexible tool. The fault injection can begin with the execution of the experiment, or with a time delay specified by the developers. The end time of the fault injection must be entered in order to specify the duration, so that ExhaustiF SWIFI can then begin the next injection. After each injection, ExhaustiF SWIFI takes a data reading, either right after the injection or with a specific time delay. This is the final screen before executing the experiment. Here, the developers can choose the type of faults that will be injected. In the fault group, the user can choose from the 5 fault injection types: software, hardware, processing, network system, or file system faults. Once the fault group has been selected, the developers can choose in what part of the system the fault will be injected. And in this case, the functional unit selected is the memory. Within the functional units, there are sub-classifications, and in this case, the part of the memory chosen is the RAM memory. All menus are dependent on the previous ones. Therefore, after selecting a fault option, the following menus are changed accordingly. The fault condition can be transitory or permanent, and here we have selected transitory. Finally, the fault type can be chosen from setting a value to a specific memory address or carrying out an arithmetic operation, and in this case, we have selected to set a value to a specific address. After carrying out the experiment, the data can be viewed in a numerical or graphical format. Here, the test results can be seen in the numerical format, which enables the developers to view the data which has been collected. In addition, the developers have the option of viewing the test results in the graphical format. This is very useful because it allows the developers to see what happens after injecting the fault in relation to the same execution without an injection. In this case, we can see the exact point where the injection began and how the value of the monitored memory address changed. ExhaustiF SWIFI gives solutions to software problems, which affect both managers and developers. This tool is able to generate situations which are otherwise very difficult to recreate. By simulating all the possible software running conditions, ExhaustiF SWIFI is able to discover where your software is most vulnerable. ExhaustiF SWIFI is easy to integrate with other Eclipse-based software applications. And MTP offers reliable online technical support. Not only does ExhaustiF SWIFI help your company fulfill their safety and reliability regulations, but it also finds your software faults before your clients do. If you are interested in ExhaustiF SWIFI, we offer a free individualized report with a list of possible faults to be injected in your system. We only need a description of your application together with some technical information. ExhaustiF SWIFI has various purchase options. You can buy the ExhaustiF SWIFI license, which includes a 1-year maintenance guarantee, or contract MTP's consultancy services, where our consultants use ExhaustiF SWIFI to help you find your software errors. As a special offer, you can purchase ExhaustiF SWIFI with a 2-year payment plan option, which includes the tool together with the maintenance guarantee. Remember, ExhaustiF SWIFI can be the solution to find weaknesses in your software.